Earth's early ocean, a single vast water body surrounding the supercontinent Pangaea. This ocean, called Panthalassa, was the first ocean on the Earth. And after the years and the eons, this ocean became the actual 5 that we have today. Welcome to Ocean Science. Today I will explain you why we have 5 oceans. Pangaea, the biggest continent that we had on Earth, begins his split 200 million years ago. With this division on the continents, the division on the oceans has born. And here the main characters are the tectonic plates. Why these plates are so important? Because they have their own moves. But how they move? They are giant, more than a continent, and they still moving? Yeah, this is because they have 2 main ways to move. One place is the mid-ocean ridge. Here the plate creates a new ocean crust. So it starts to create from one way and to another. And the plate starts to move forward from the ridge. The other place is the subduction area. So if in one place we're creating the ocean crust, in another place this crust is consumed. So here, for example, in the coast of Japan or even in the Chilean coast, here the subduction area makes this destruction of the ocean crust. And these places in particular forms part of the Ring of Fire, having this name for the volcanic and seismic activity that can generate many disasters as volcanic eruptions, earthquakes, or even tsunamis. Okay, so we see how a tectonic plate moves, creating new crust in one place and destroying the old one in another one. But how this divide an ocean? So how we can have now 5 oceans if in the beginning we have only 1? When we see the evolution of our planet from Pangaea until now, we see many changes on the different continents. And we arrive to a situation that we have today. With this continent, we can see clearly these different lines that we put to say, okay, here we have the Atlantic Ocean, here we have the Indian Ocean, and here we have the Pacific. But the Southern Ocean and the Arctic Ocean, they are touching all the other oceans. How we can have this division and it's 5 and not 6 or 4? So the main point here is the salinity. The salinity changed the density of a water. We see that with the salty water and the fresh water, and we have many examples on the planet. We have different salinities on each one of these oceans. So here we have a main characteristic that divides the oceans. But I say density, and the density is not always correlated with the salinity. Another thing that changed this is the temperature. And we see how we have 2 main divisions. We have the Southern Ocean and the Arctic Ocean. This division is not only for the fresh water that we have from these places that became part of this zone and have this ocean with less salinity than the other ones. That is true, but it's not the only thing. The thing is the temperature. Here we have less temperature than in the other oceans. So that makes a particular thing with the density becoming a more dense water than the other ones. And this thing of the temperature is not also for the density and remains there. The ocean creates masses of water. We can identify them when the water goes down, generating a downwelling, and traps all the characteristics that water have in the surface. So the oxygen that they have, the different concentration of the different nutrients, and the salinity that this water have. And the main points that the water masses are created are the poles, the South Pole and the North Pole. And this is important because the water that is different from other ones became a deep water mass. So we can identify the different water masses depending on the characteristic that we have. And as I said before, we have this formation of deep water masses. Also, we can identify these water masses, and not only on the oceans. In the different sea, we can have these situations. On the Mediterranean Sea, we have also formations of deep water masses, and we can identify them from another water masses. And here we have another fact. The Earth is rotating in one direction all the time from the poles. Has a little angle from 0, so it's 23, but it's still a sphere that rotates in the H. So the currents that we will have on the oceans and on the winds from the Arctic zone and the Antarctic zone will be less irregular than the other ones. So we will have a continuous movement of the same water. So this is important only for maintaining the characteristics that we have on one water. If we have one river that puts some fresh water into the ocean, depending on the situation of the currents, how this affects to the ocean. In this case, if we have a lot of fresh water from the glaciers and we put it on the ocean, but these currents still rotating in the same area, we can divide this from the other oceans for the change on the characteristic. So this water doesn't mix with the other ones. Okay, so we see how different they can be from the temperature, the salinity, how the different waters can form going from one point to another. But as we see on the map, these oceans are together. So we can consider it one big ocean in a strange way, but these water masses are touching each other. So how they still divided? These water masses are not completely divided. We have a system of currents that maintains this mixing from one ocean to another, but the chemical characteristics that we have of each one are accurate. And these differences are not only in the chemical part. So if we have different chemics of the water, we will have another biodiversity. So we see that on the Southern Ocean, that this division that we have from the Southern Ocean, from the other oceans, became so important for the species that live in these characteristics. And with the current climate change that we have and melting of the different glaciers, these characteristics change because the freshwater fluxes increase from the rains that became rivers and became part of the ocean until the glaciers that melts and became part of the oceans. And the final question that we have, in the future, these currents can mix the different oceans that we have today to become one big ocean again? This is complex because the tectonic plates are still moving, so new oceans can appear. This is a thing for another video, but it's interesting to know that this is still moving. And the mixing of the waters is slow, it's very, very slow. We have these cycles of a water mass from the creation of a water mass until became part again of another ocean that are around 1,000 years. So with these times that we have and the different changes that the oceans are suffering right now, we don't know if in the future this will become one ocean again. That is all for today. Thank you for watching. If you like this content, subscribe to the channel, and I will see you the next Saturday at 12 with the next video. Bye bye!